Hello. Okay, question 3. And if you read question 3, it says try to solve these equations. Note the try. It is a bit of a hint there. And it says using technology as well. So, hmm. Well, if we look at these two equations, this one's easy to put into the calculator, and this one I could rearrange and get y on its own. But you know what? I thought just to show you something different, I'm going to use Desmos this time. Pretty much the same thing as GeoGebra. Okay, so GeoGebra or Desmos. We'll flick over here to the screen. I know I've walked off again. So www.desmos.com, start graphing. And it's a really nice clean graphing package here. And what I like about these is the input is super friendly. So we want 3/5. That's 3, and I think it's a forward slash, isn't it? 3/5, and then just press the right arrow. So you're not, you don't want to be down the bottom of the fraction down here. Press the right arrow to get there. 3x minus 1, and then we got the graph there. You saw it there drawing itself as we were typing it in. And the nice thing about this, and why I chose this method, is because I can simply also type the second equation in, which is in the general form. This is general form. The first one I call slope intercept form, or I don't think it was my idea, but yeah, it is called that. 3x minus 5y equals 5, and then it's drawn. Now have a look what happened there. Just so I'll just go back a couple of steps. Look, y and then equals 5, and it draws it straight over the top of the other one. Well, for those of you who've been in class, we know what that is, but if you've been at home all this time in hiding, don't blame you, um, then you'll know that it's because it's exactly the same graph. And let's have a look. I'll switch my camera back on because I'm going to show you how we can see that. Let's have a look at this equation here. Okay, well, we could move this minus this 3/5 over here. We could subtract it over the other side like this. Okay. And remember, this is the first equation. This is the second equation we had. We could take this equation and we could multiply it by -5 as well. So if we multiplied this by -5, we'd have 3x minus -5y, and -5 times -1 is 5. And guess what? Well, apart from the fact I did it wrong there, yuck. We end up with that equation. So we're just showing that you can go from that to that to that, and it is the same as the second equation. So both equations are the same. And now it does actually say state how many solutions there are. So think, what does that mean? Well, what that actually means is how many values of x and y satisfy both of the equations. Yeah, they work in both of the equations. Well, since as the equations are on top of each other, the lines are on top of each other, there are infinitely many solutions. Okay, that is that any solution, any point on this line is also a point on that line. So because lines go on forever and ever and ever, okay, there are infinitely many solutions. I'll say that again, because any point that you choose that on this line, it must also be on this line because they're the same line. So infinitely many solutions. So I'll stop that recording there.